The front end of a Sledge combined with the front end of a Kraton, nitro, electric, four-wheel drive, four-wheel steering, let's go. We're gonna do this by combining an Arrma Kraton chassis with a Traxxas Sledge chassis, driving one end with a nitro motor and the other end with an electric motor. And to keep things really spicy, we're gonna be using the front ends of both cars so we can actually have four-wheel steering, which should be really, really fun. Getting these two platforms to work together is probably gonna be the hardest engineering challenge I've ever done. I believe we're gonna go ahead and put the Sledge chassis on top of the Kraton chassis. That way we don't have to worry about these reinforcements getting in the way. Mounting them together on this side should be fairly easy. We can just use these bulkhead holes, but this end is gonna be quite a bit more complicated. Because we need to leave space for the Kraton steering and drivetrain components, we're gonna have to chop some of this chassis off. Before we make that cut, we need to decide where we're gonna put this nitro engine, and before we do that, we need to decide if the nitro is gonna drive the back or the front. There's not gonna be any connection between the electric motor and the nitro engine. This means the two won't be fighting each other, which should be a big advantage in this system. And if we put the nitro engine in the front and the electric motor in the rear, the electric motor is gonna get more traction, which will allow it to push the car harder and faster. But my concern is that this nitro engine might end up over revving, because when you're under acceleration, the front end of the car comes up, and there really won't be anything stopping this from revving too high. And we've seen previously what happens when we do that.
Isn't it incredible?
Because of that, I think we're gonna put the nitro engine in the rear and the electric motor in the front. This also gives us the advantage of good front brakes, which we wouldn't get if we had the nitro engine in the front. That being said, they both have advantages and disadvantages. Let me know down in the comments which way you would have gone with it. The length of this vehicle is gonna be fairly arbitrary and is gonna be set by where we mount these two chassis together. The most important thing is that we cut this short enough so it doesn't interfere with the center differential on the Kraton. And I think for simplicity's sake, we're gonna cut it right behind these reinforcements right here. And we're gonna use my CNC mill to make a nice clean cut here. Of course, you could use an angle grinder or something like that. As a matter of fact, we're gonna use an angle grinder to cut the front end of this off because it's not quite gonna fit, but to get a really clean line, I wanna use my mill. And now that we have that rough cut done, we can take some basic measurements, go into CAD, and create a very simple file that's just gonna give us one line to cut. Have the automatic tool changer select the 1/8 inch single flute end mill and cut this thing down. While that's cutting, we need to address what I think is gonna be one of the biggest challenges on this project, and that's the steering geometry on the Sledge. On this car, and on most cars, as you can see, the steering axis is actually leaned back. This is known as positive caster. That positive caster creates an inherent stability when the car is moving forward. It makes the steering want to stay centered, which keeps everything nice and smooth and going straight. The problem is that same inherent forward stability results in inherent backward instability. As you can see, the car was trying to shake back and forth as it was going backwards. In reverse, the car becomes nearly uncontrollable. To put it simply, positive caster is stabilizing because it puts the contact patch of the tire in front of the steering axis of the car. This means when you turn and that contact patch gets pushed off to the side, the weight of the car naturally wants to push it back to the center again. In reverse, you have effective negative caster, which basically does the exact opposite, which is why it's so unstable. The safe way to eliminate this would just be to use the rear section of the car for the rear section of the hybrid, but I really don't want to do that. I want to have four-wheel steering, so let's see if we can reduce this problem as much as possible. A little bit of the positive caster comes from the fact that the chassis is actually tipped up in the front, but the vast majority of it comes from these C-hubs, which actually have a big angle here on this lower pin. I'm hoping we can flip these around and reverse that angle. I looked at the stock hubs before doing this, and I don't think they'll be reversible, but these aftermarket ones are designed slightly differently, so they might actually work. Okay, so now if I take the C-hub from the right-hand side and put it in the left-hand side, we actually end up with negative caster, which means when this thing's going the wrong direction, we'll end up with positive caster, so this might actually work. Now the question is the steering still gonna fit? It looks like it's gonna fit in the C-hub, and that's great. But both the upper link and the axle are hitting this shock. I think we can fix that too, though. All I'm gonna do is take the shock and move it to the outside of the arm, and that gives both our upper link and our axle plenty of clearance. And there we go, we've effectively reversed the caster in the front end. In theory, in its current setup, this should make it less stable going forward and more stable in reverse. But as the late great Albert Einstein once said, theory is lame, let's find out. And I can tell you already, it feels really weird going forward. I wouldn't call it unstable, but it's certainly not stable. And we've got some pretty interesting steering geometry going on, including some bump steer and some really weird camber, but let's see how it does going backward. Obviously, we're gonna be steering from the rear here, so it's not gonna be the best, but yeah, it definitely does feel a little bit more stable, and I think that's gonna work. Now, are all these steering geometry changes going to be perfect or a complete disaster? I have no idea. We're just going to have to find out together. Speaking of finding out together, that cut is done, and just look at the surface finish on this. It's absolutely beautiful. Now, I know you could make a cut like this by hand, but you could never make it look that nice. And now we've got a reference surface for the rest of the modifications we're going to have to make. However, that brings us to our next big challenge, and that's, will this nitro engine even fit? And no, unfortunately, it's not going to. The gear on the nitro engine actually lands way up here, and we're already running into the steering back here. However, I think I have a solution. We should be able to take this differential and flip it around 180 degrees, and that's going to give us just enough room for the nitro engine. Of course, in order to do that, we're going to have to do some modification to this area of the chassis. What we don't absolutely have to do is replicate this slot, because the spur gear we're using is small enough that it won't interfere. However, I still am probably going to end up cutting it, and that's because this slot isn't just for clearance on the spur gear. This slot allows debris to fall through, so if something gets between the spur gear and the chassis, it doesn't jam it up. And with how close this spur gear is going to be, I think that's going to be really important. Fortunately, though, it does look like pretty much everything else is going to clear. We do have one thing that might interfere, though, and that's the exhaust. For fitment reasons on the Funko, I actually ran the exhaust straight out the back of the motor, and many of you rightly said this could have been causing a problem. A nitro engine allows fuel and air in and exhaust out through piston porting. As I turn this engine, you can actually see the piston covering and uncovering the exhaust port. It does the same thing with the intake ports on the other side, and when the piston's all the way down, they're both open at the same time. To prevent the engine from just pushing all the fresh charge air right out the exhaust, we have a specially designed exhaust chamber where each exhaust pulse comes out and then is reflected back. That back pressure actually keeps the fuel air mix inside the cylinder. The timing of when that happens is really, really important, and so these exhaust pipes are designed specifically for that timing. When you have the full manifold on here, it physically takes more time for those pulses to travel back and forth. Removing it means there's much less time. On paper, this moves the RPM range that you're going to get your most power up, but in practice, it might move it so far up that it's actually out of the operating range of the engine itself, meaning you'll never get on the pipe. This is also a very cheap exhaust pipe because I figured I was probably going to be chopping it up and modifying it. So to fix both those problems, I got this tried and true Dynamite 063 mid-range pipe, and we're going to be running it exactly as it comes out of the package. The question is it going to fit with the engine in its place? If we put the pipe on here, we can see that there is a close interference here with the steering, but this engine's actually probably going to be raised up a little bit. So other than some potential melting issues, I don't think we're going to have a problem here. And I am very confident that this pipe is going to work properly with this engine. However, before we start mounting any of that up, we need to get the Arrma electric side installed and make sure there's not going to be any interference issues here in the middle. Now for the center module, I'm pretty sure all this stuff's gonna fit no problem, though we might have a clearance issue with the bottom of the motor and the other chassis. Is this gonna fit under here? And yes, it is. Now finally, setting the Arrma battery tray and the nitro motor on here, it looks like we might have to do some trimming in this area, but this all looks like it's gonna fit. And I gotta say, guys, this monstrosity is starting to look absolutely awesome. I cannot wait to see how it turns out. I think we might even be able to trim up this Traxxas center brace and mount it on the Arrma center differential. That's gonna look awesome. Now it's time to talk about mistakes, because I've made one. This entire time I've been talking about putting the nitro engine here. Unfortunately, the nitro engine rotates counterclockwise from the front, which in turn rotates the drive shaft clockwise, and as you can see, that would be backwards. I believe when I was initially looking at this, I forgot that the front end was going to be on the back. I had a few people comment in my previous video that two-stroke engines can run either direction, and while that can be fundamentally true, it's not true for this particular engine. The intake valve for this engine is part of the crankshaft, and that intake valve is timed properly only in one direction. So while this might technically run the other way, it's not going to run well, and certainly not going to make maximum power, which we need here. Now, fortunately, in this particular setup, it looks like I'm going to be able to flip the engine around the other way without too much trouble. There's just enough clearance in here for everything to fit, though with it there, we're going to have to rethink this battery tray situation. I'm sure we can figure something out, though. I had been planning on reusing this 3D printed mount from the last video, but unfortunately, that's not going to work here. We're going to need more low-profile mounts, and this is a great time to talk about when you should and should not fabricate something. I designed and 3D printed this mount because it needed to be a very specific shape, and it needed to be through-bolted on the carbon fiber. We don't need any of that here, and I found these low-C aluminum mounts for $14 shipped. Between the cost of the materials and how much time it would take to machine something similar, we would be spending a lot more than $14, and these are going to work perfectly. All we need to do is figure out where these holes are going to go, cut some slots, and then we can get this engine mounted up. In order to properly locate the engine, we're going to need to install the clutch and flywheel. This got a little bit torn up in our over RPM excursion.
Isn't it incredible?
So I went ahead and picked up a new clutch. In case you're not familiar with these are known as centrifugal clutches. They are very simple in operation. All that happens is as this spins faster, these get drawn out by centrifugal force. They bear against the inside of this clutch bell, and that's what connects the engine with the gear when you accelerate. Most of these nitro engine clutches install exactly the same. You've got this tapered collar here. The flywheel goes down on top of that. A nut holds the flywheel on, and then the clutch bell installs right on top of that. Depending on your setup, you may need to do some shimming to make sure that you actually have a little bit of play in this clutch bell and that nothing is jamming up. This looks like it's going to work fine right out of the box though. And it matches the blue of the engine as well as the blue of the Traxxas side of the car. I have to admit, matching the Traxxas side of the car is not something I ever thought I would say on this channel, and it makes me really excited to see how this thing's going to turn out. However, flipping this motor around has created another problem. I was going to use a 48 tooth spur in order to try and get the gearing as equal as possible between the nitro engine and the electric motor. But unfortunately, we've got some serious clearance issues with the flywheel and the center differential mount. In order for it to fit with this spur, I'd have to take this whole corner off, and I don't think that's going to work. Fortunately, it looks like this spool was designed so it can take standard spur gears, and I have this stock 52 tooth gear, which should help quite a bit. And I'm glad we're taking this apart anyway because there's zero thread locker on these grub screw pins. Looks like that pin just holds this cup on, and if we take this bearing off, yeah, it looks exactly the same as the stock gear. And with a good healthy amount of thread lock on these, let's get this back together. You know, guys, the more I'm looking at this, the more I realize that this is really going to be a problem. This center differential is only held down with 4 screws, and it looks like we're going to have to cut most of one of these corners off in order for this to actually fit. But I've got an alternative idea. Why don't we try reducing the diameter of this flywheel on the CNC machine? Now, this is going to be tricky because in order to keep this balanced, it's going to have to be perfectly machined. But there's a trick for doing this. We're going to take this scrap piece of plastic, and we're going to cut a hole in it that's the exact same diameter as this bottom piece here. Then we can stick it in that hole and secure it with a screw. Doing that will perfectly locate this and allow us to cut the outside really concentrically. This is something I've never done before, so let's see if it'll work. All I'm gonna do is create a simple program that cuts the diameter of that bottom feature, as well as a hole for our screw. Then I'm gonna mount this scrap piece of plastic up, go ahead and cut that out, mount up our clutch, and let's see what happens. Okay, well, so far it appears to be cutting pretty well, and as you can see, the final result is just about perfect. Concentricity could not be better. The finish is nice, and we took quite a bit off of this, which should give us a lot more clearance. We have made the flywheel quite a bit lighter, which might be a problem for idling, but we're just gonna have to find out. This is something you definitely couldn't do by hand, and I want to mention that it took me about 2.5 hours to actually figure this out, get it programmed, and get it cut. Mostly that's because I don't know what I'm doing, though. Overall, I couldn't be happier with this. Let's get it back together. As you can see, now the clutch bell is actually the widest part, and we've got plenty of clearance to that motor mount. I don't think we're gonna have to trim this at all, which is really awesome. Next step is to go ahead and get these slots cut and get this mounted up. I'm actually gonna use the exact same stock screws that came on the original electric motor mount, and cutting these recessed slots is another thing that could really only be done on a CNC machine, and we are gonna have to have them recessed because this is gonna be right up against the other chassis. Getting these located should be fairly straightforward. Basically, all I'm gonna do is put the motor where I think it needs to be, then make a few marks with a pencil, measure those marks out, measure the hole spacing for this engine mount, go into CAD, create the model, then we're gonna 3D print it out. I 3D printed this rather than just laser cutting it out of paper because I need to make sure these slots work properly. But first, let's get this set in place here. We're using the cut end of the chassis as a reference, as well as this side. And then we'll set the engine on top and make sure everything looks like it's gonna line up. And yeah, this all looks really, really good. And then finally, I just need to make sure the slots I created work with these screws, and they do fit in the slots, and they're nice and flush. So now we can just take this chassis, flip it over, load it up in the machine, cut out the slots, and here we go. I have to say, guys, this thing turned out absolutely perfect. As you can see, it perfectly cut out the pencil marks I had here before. The counterboard slots look fantastic. These stock screws are gonna fit absolutely perfectly. And if we set the differential back in here, it looks like the engine is gonna line up really, really well with those slots. If you like seeing projects with these cool machines, make sure to get subscribed. I've got a machine coming that you've never seen before, and it is gonna absolutely blow you away. In the meantime, though, I need to go ahead and get this mounted up and get the exhaust and fuel system temporarily installed because we need to make sure this engine actually runs before we do the final assembly. Okay guys, well, a little bit of a problem. As you can see, there's a flat here on this header, and that's because the header is designed to be on the other side of the engine. So we're just gonna have to go ahead and sand a flat right here so it fits on the wrong side. There we go, that's better. Now we just need to get this mounted up, install a throttle servo and a fuel tank, and let's go see if this thing's gonna make some noise. She's obviously running really rich, but she fired right up. There is one problem I noticed, though. I'm not sure if you're gonna be able to see it, but if you look closely at that clutch bell, it's wobbling all over the place. This is not an issue with a bent crankshaft because the crankshaft itself isn't moving right now. This is a problem with the clutch bell itself, so I'm gonna have to order a new one. While we're waiting for that to arrive, let's get the electric side ready to go. The main thing we need to do is swap out this center differential for a center spool. I'm gonna take this front output cup off of the spool. This will give us more room for that throttle servo that's gonna end up right here. Removing that front output cup does remove some of the support for the front bearing. Fortunately, that bearing's also supported by this lip right here, so I don't think it's gonna be a problem, but we're just gonna have to find out. I gotta tell you guys, I love doing these kinds of projects and I love sharing them with you. Let me know down in the comments if you have any awesome ideas for future projects, and maybe you'll see it on here one day. Slide this in here, and then we're gonna go ahead and swap this output cup around because I took the wrong one off. Now we can put it back together. Now we just need to put this top brace back on. Install the first of 2 steering servos. And the front end of this monster is ready to go. And now our replacement clutch has arrived. Let's see if this new clutch bell is any better than the old one. To get to it, I'm just gonna pull a spool out of here. That's a lot easier than pulling the whole engine. And off with the old one, then right back on with the new one. And somehow, this one's even worse. This front bearing is completely trashed right out of the box. Look how locked up that is. Hopefully I can swap the bearing out of this one, but I would definitely not recommend getting a clutch from GTB Racing because that's 0 for 2. All right, so it turns out there's a defect in the bore the bearing was in, and it was squeezing the bearing so hard that it jammed the bearing up internally. These small bearings depend on really tight tolerances to work properly, and if you squeeze them really hard, even though they're made out of steel, they'll jam up like this one did. Since we already modified this flywheel, I don't really have any choice but to use this. Fortunately, a few seconds with a diamond bit on a Dremel took care of the blemish. Unfortunately, it doesn't matter because this clutch bell is just as wobbly as the other one was. Since there's nothing I can do about it, we're just gonna put this back together and pretend we didn't see it. Speaking of which, it's time to finally put this thing together and see what we've made. Now, I could map out the holes in this chassis and then create a 3D model and cut them out using the CNC machine, but this time we're just gonna keep it simple. I'm just gonna use a pencil to mark these holes on this chassis, drill them out, and then we're gonna bolt it together. And here we go, guys. This thing is all put together and it looks absolutely nuts. I was even able to get the Traxxas tower to chassis brace installed. I just trimmed it up and installed it on the Arrma center. I did go ahead and omit the battery tray. We're just gonna use Velcro for now because the battery tray really doesn't wanna fit in here. Obviously, there are options if we wanted to do this permanently though. All we need to do now is put some wheels on it and see how this thing runs. Before we do that though, I'm curious to see how much this thing weighs. Obviously, this is without body, wheels, or tires, but let's see what we've got. Right at 11 pounds, 15 ounces, so about 12 pounds. That's really not that bad. Before we go out, I'm sure the 80,000 of you that watched the previous video are wondering, how am I using this engine? Didn't we blow it up in the last video? The story behind that is a story of loss, but not quite the loss you're thinking. See, this engine didn't actually blow up. All that blew up was the clutch. You can see bits of the bearing here, and it had jammed up and stopped working. The footage that I lost when I tore this thing down showed you that it was in perfect running condition and that we could go ahead and use it. That's the bad news. The good news, of course, is that we can use it, so let's go bash this thing. Before we run this thing in hybrid mode, let's check out the steering options. We've got front steer, and of course, being front-wheel drive electric only, that feels kind of weird. It's actually not that bad, though. It's pretty stable with how long it is. Of course, we've got rear steer, and that definitely feels very, very weird. It's kind of dragging itself around and doesn't really want to turn at all. And of course, we've got crab steer, which doesn't turn, but just slides to the right and to the left. It actually does turn a little bit, but that's pretty silly looking. I don't think I've ever seen a basher do that before. And then finally, we've got full 4-wheel steering, which actually makes some nice tight turns, even with being just front-wheel drive. It actually turns pretty darn well. Obviously, we're still not going to get the traction we will with full 4-wheel drive, but let's see if we can do a little bit of a jump with it. Get it over here. Boy, it really is responsive with that 4-wheel steering. Get a little bit of a jump out of her. Yeah, it doesn't really like that. Let's get a little bit more speed up. All right, here we go. More speed. No, it just doesn't have the traction for that. Let's fire up the nitro.
Alright guys, I have to say I've been having a real bear of a time keeping this thing running. I don't know if it's because it's not broken in yet, or because maybe I don't know how to tune it, or maybe the carburetor just doesn't like to keep it tuned, but so far it's been a real struggle. We've got four-wheel drive, rear-wheel steer here, and it actually is working pretty well now. This is the longest I've had it running, so maybe I finally got it tuned right. Let's put it into four-wheel steering. Alright, with four-wheel steering, this thing has got some serious turning responsiveness, and it is running pretty well. It's actually still really rich, and it is still being broken in, but it does run, it does jump, and yeah, it seems to be running okay now. It is definitely a very different experience from what I'm used to. It's very turn happy in the rear. I think we could probably dial a little bit of that rear steer out, but it actually is pretty fun. And to be honest with you, oh, this is better than I thought it was going to be. I've been struggling with this engine for a while. I did some research online, and apparently the carburetor that's on here isn't the best. I did try using that Hobeo carburetor, and it didn't work any better for me, but now it is really cooking. Oh, this is great. It's getting very, very dirty. Fortunately, I've got that Motor Saver air filter on there, so that should keep the intake air clean. Gonna jump. Oh! And yeah, in spite of the fact that I've really been struggling with this engine, I think I would call this a success. We've got a hybrid car here. Is it the fastest thing in the world? No. Could it be a lot faster than this? Probably. I think if we had an engine that could actually tune better, we would definitely be doing better, but this thing sounds awesome, and it drives really, really interestingly. This is unlike anything I've ever felt before, and yeah, guys, even though it's not perfect, I'm going to go ahead and call this one a success. One more thing I want to do before we wrap this up. I went ahead and switched the motor wires around, so now it's rear-wheel drive electric only with that four-wheel steer, and it feels pretty crazy.
Guys, that was absolutely awesome, and as a proof of concept, this thing worked really, really well. Having the electric motor and nitro engine separated eliminated most of the problems we previously had. The electric motor provided plenty of braking, and they seemed to work really well together. Unfortunately, I just never could get this thing tuned properly. I don't know if maybe there is still something wrong internally, or maybe I just don't know what I'm doing, but I have tuned quite a few engines in the past, and I've never had quite as much trouble as I had with this one. With that being said, plenty of people have had great luck with these ZR32 engine, so it's probably just something I'm doing wrong. And this is where I'm going to ask for your help. I bet one of you guys can get this thing running right, and if you think you can or just want to give it a try, drop a comment letting me know what you'll do with this engine, and I'll pick one of you guys at random to send it to. Of course, you got to make sure you're subscribed and like the video in order to win. Overall though, I have to say, as a concept, with the nitro engine driving one end and the electric motor driving the other, especially with four-wheel steering and all the other craziness we had going on, this thing was really, really cool, and there is definite potential here. I do want to reiterate though, of course, this is not a final product. This is more of an experimental test bed, and what looks like success to me might look different from what success would look like to you. Let me know down in the comments what you thought about this. What would you do differently? How would you improve it? While you're down there, make sure you hit that subscribe button, and when you're done, check out one of these awesome videos.